Still wearing the same tidy whities you grew up with? Duluth Buck Naked is getting people across the country to change their underwear. With no pinch, no stink, and no sweat, Duluth Buck Naked underwear feels like you're wearing no underwear at all. Plus, they're treated to fight odor, helping you to stay fresh all day long. Still not convinced it's time to change your underwear? Shop Buck Naked at Duluth Trading Company.
Day 2 of my exclusively adult Virgin voyage. I've come to discover an amazing new use for my phone, shaking it to have champagne delivered to me anywhere on board. Tomorrow, it's bubbly in the bubbles. That's a nautical term for champagne in the hot tub.
Come set sail on an award-winning adult Sony voyage. To learn more, visit virginvoyages.com or contact your travel advisor today. Now we're voyaging.
This is SpaceTime, Series 25, Episode 94, for broadcast on the 9th of September 2022. Coming up on SpaceTime, the Perseverance rover finds sands on Mars can be green as well as red. Discovery of a new planetary nebula. And the United States launches an important new spy satellite aboard an Atlas V rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The accepted view of Mars is red rocks and craters as far as the eye can see. And that's pretty much what scientists expected when NASA's Mars Perseverance rover landed in Jezero Crater a year and a half ago. Scientists selected the Jezero Crater landing site primarily because of its history as a lake and the location of what should be a rich river delta full of sediment. The area was part of a rich river system back when Mars was a warm, wet world with liquid water, air, and a magnetic field. But what Perseverance discovered once it reached the ground was something quite different from what scientists expected. Rather than the expected sedimentary rocks washed by rivers and accumulating on the lake bottom, many of the rocks they found are volcanic in nature. A new study by planetary scientists Roger Wiens and Brian E. Horgan from Purdue University showed that the rocks are actually composed of large grains of olivine. The findings, reported in the journal Science and Science Advances, are based on data collected by Perseverance's SuperCam, which helps analyze the rock samples and determines their type and origin, and its Mastcam Z cameras, which puts the samples into geological context. Wiens says that as scientists began studying the results, they realized that these layered igneous rocks found on Mars look very different from the igneous rocks found these days on Earth. In fact, they're more like the sort of igneous rocks Earth had early in its history. The rocks and lava the six-wheeled rovers examining on Mars are nearly 4 billion years old. Rocks that old exist on Earth too, but they're incredibly weathered and beaten thanks to Earth's active tectonic plates as well as the weathering effects of billions of years of wind, water and life. But on Mars, these rocks are pristine and therefore much easier to analyze and study. Understanding the rocks on Mars, their evolution and history, and what they reveal about the history of planetary conditions on Mars helps scientists better understand how life may have arisen on Mars if it ever did, and how that compares with early life and conditions on the ancient Earth. Horgan says one of the reasons scientists don't have a great understanding of where and when life first evolved on Earth is because the rocks dating from that time period are mostly gone. And so it's hard to reconstruct what ancient environments on Earth would have really been like. But the rocks that Perseverance is travelling over in Jezero Crater on Mars have more or less just been sitting there on the surface for billions of years, just waiting for the rover to discover them. So, scientists can use the conditions on early Mars to help them extrapolate the environments and conditions on Earth at the time when life was beginning to arise here. Understanding how and under what conditions life began on Earth will help scientists know where to look on other planets and moons, as well as leading to a deeper understanding of biological processes here on Earth. The search for life is one of Perseverance's main goals, and one of the reasons it landed in Jezero Crater in the first place. discovering the potential for habitable environments in something as uninhabitable as Jezero Crater's aged lava flows raises hopes for scientists of what lies in the sedimentary rocks the mission is now beginning to examine. We'll keep you informed. This is SpaceTime. Still to come, astronomers discover a large evolved planetary nebula 4,500 light-years away in the Messier 37 open star cluster. And a United Launch Alliance Atlas V Centaur rocket has successfully placed a new American early warning spy satellite into orbit. All that and more still to come on SpaceTime. Astronomers have confirmed a large and evolved planetary nebula some 4,500 light-years away in the Messier 37 open star cluster in the constellation Auriga the charioteer. This is only the third planetary nebula ever detected in an open star cluster. Open star clusters are loosely bound groups of a few hundred to a few thousand stars. They were all thought to have originally been formed at the same time in the same molecular gas and dust cloud. Open star clusters are thought to generally only survive for a few 100 million years before all the stars in the cluster drift off on their own. However, some of the more massive open clusters have survived for a few billion years. The new findings, reported on the pre-press physics website archive.org, are based on measurements of the radial velocities and proper motions of the central white dwarf associated with this planetary nebula, which is consistent with the motion of the overall M37 star cluster. M37 has a radius of about 10 to 13 light-years, with around 1,500 solar masses, and it contains at least 500 identifiable stars. As for the planetary nebula, well, it's bipolar, indicating a dust ring existed around the progenitor star before it died and became a white dwarf. The nebula has a radius of about 5.2 light-years and is thought to be around 78,000 years old. This is SpaceTime. Still to come, a United Launch Alliance Atlas V Centaur rocket successfully places a new American early warning spy satellite into orbit, and later on September SkyWatch, we examine the September Equinox, the constellations Capricorn and Aquarius, and the Aurigids and Epsilon Perseids meteor showers which will dominate the night skies of September. All that and more still to come on SpaceTime.
This podcast brought to you by Ring. Save big right now on select Ring doorbells and cams and give the gifts that keep on giving. Find gifts that help handle all those deliveries.
Hey, again? Leave it behind the chair with the others.
And gifts that tell you when creatures are stirring.
Biscuit, get away from the ornaments. Good girl.
Shop the Black Friday sale and save up to 40% on select devices at Ring.com. That's up to 40% off right now at Ring.com.
A United Launch Alliance Atlas V Centaur rocket has successfully placed a new American early warning spy satellite into orbit. The space-based infrared system Geosynchronous Earth Orbit, or Cerberus GEO-6 spacecraft, will monitor the launch and flight paths of enemy rockets and missiles for the United States military. The mission blasted off from Space Launch Complex 41 at the Cape Canaveral Space Force Base in Florida. It's one of the last missions to be launched by the current Atlas V rocket, which will eventually be replaced by the United Launch Alliance's new Vulcan Centaur rocket. The Cerberus GEO-6 joins 5 other similar satellites, completing a ballistic missile tracking constellation in geostationary orbit 35,700 kilometers above the Earth. Built by Lockheed Martin, the 4,500-kilogram spacecraft uses the company's LM-2100 combat platform and is equipped with enhanced electronics, maneuverability, and surveillance capabilities. These surveillance satellites work by using high-resolution infrared cameras to detect the telltale heat signatures of rocket exhausts. The earlier you can detect these exhausts, and the more accurately you can follow them as they lift off into the atmosphere and beyond, the better you can determine where they're eventually going to come down, thereby providing more warning time. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to turn our eyes to the skies and check out the night skies for September on SkyWatch. September was the 7th month of the year in the old Roman calendar, which had just 10 months. That's before the addition of January and February. That 10-month year is still reflected today in the names September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It really wasn't until the Gregorian calendar that January the 1st marked the start of the new year, but in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March the 25th, marking the Feast of the Annunciation and Easter. The earliest recordings of a New Year celebration are believed to have taken place in Mesopotamia around 2000 BCE, around the time of the Northern Hemisphere vernal equinox in mid-March. A variety of other dates tied to the seasons are also used by various ancient cultures. The Egyptians, Phoenicians and Persians began their New Year off with the fall equinox, and the Greeks celebrated it on the winter solstice. While the Jewish New Year, or Rosh Hashanah, the Festival of Trumpets, occurs in September, where it marks the beginning of the Northern Hemisphere cycle of sowing, growth and harvest, and apparently the creation of Adam and Eve, according to the Jewish Bible, the Old Testament. The September Equinox will take place at 11:03 in the morning of Friday, September the 23rd, Australian Eastern Standard Time. That's 21:03 in the evening of Thursday, September the 22nd, US Eastern Daylight Time, and 1:03 in the morning on Friday, September 23rd, Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equinus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun, and Earth's axial tilt is pointed to the same direction in the sky, regardless of Earth's orbital position around the Sun. So on other days of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. Now, it's also worth noting that on geological timescales, the solstices and equinoxes change because of a process called precession, which causes Earth's spinning axis to wobble like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season to occur at a slightly different time from year to year over a 21,000-year cycle. Of course, as well as precession, the Earth's orbit itself is also subjected to small changes called perturbations. That's because Earth's orbit's an ellipse, and so there's a slow change in its orientation, which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion will gradually regress through this 21,000-year cycle, unless we compensate for it. Okay, let's start our tour of the September night skies by looking towards the east and the constellation of Capricornus, the goat. The name comes from the ancient Greek tale about the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. The sudden appearance of Typhon scared Pan, the flute-playing goat boy, who tried to escape by turning into a fish and swimming away. However, he realized his cowardice before completing the transformation, and so distracted the demon by playing his flute instead. And this gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb Algedi, or the tail of the goat. It's a near neighbour, located just 39 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit across the universe. Deneb Algedi is a spectral type A white Beta-Lyra variable eclipsing binary. It's comprised of two stars closely orbiting each other. Now, astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red dwarf stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are usually about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As we mentioned earlier, Deneb Algedi is a Beta-Lyra variable eclipsing binary system. It's made up of two stars closely orbiting each other. The total brightness of the system changes, because the two component stars periodically pass in front of each other as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of Beta-Lyra systems are usually massive giants or supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives each of the stars in the system an ellipsoidal shape with extensive mass flows from one component to the other. Just below Capricornus on the eastern horizon, you'll see the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most beautiful-looking boy that ever lived, and so was carried from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way galaxy. Beta Aquarii, the brightest of the pair, is also known as Sedal Sud. It's a multiple star system, located about 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of our Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sedal Melik. It's about 520 light years away, around 6.5 times as massive as the Sun, and some 3,000 times as luminous. Next, we move to the southern constellation of Pisces Austrinus, the Southern Fish. The brightest star in the constellation is Fomalhaut, the mouth of the Southern Fish, and the 18th brightest star in the night sky. Interestingly, thousands of years ago, it was used to mark the position of the winter solstice, the Sun's most southerly position as seen from the northern hemisphere. But the precession of the equinoxes, which we talked about earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light years away, Fomalhaut is a spectral type A white-yellow star, about twice the mass of the Sun and around 16 times as luminous. It's also a really young star, only about 400 million years old. By comparison, our own star, the Sun, is some 4.6 billion years of age. Fomalhaut exhibits an excess of infrared radiation, indicating that it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral type K orange dwarf star TW Pisces Austrini and a spectral type M red dwarf star LP 876-10. Turning to the north now, there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus is the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning bolts for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Perseids, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's blurted out to a spectral type K supergiant nearing the end of its life. Astronomers are still debating as to whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one of the corners of the summer triangle. It's also home to the giant Cygnus OB2 stellar association, which includes one of the largest known stars in the universe, MNL Cygni, a red hypergiant, about 1,183 times the radius and 50 times the mass of our Sun. In fact, were it placed at the centre of our solar system where the Sun is, its surface would extend out beyond the orbit of Jupiter. It's so big it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light years away. Now, Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964, and even today it remains one of the most studied astronomical objects in the sky. The black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Little wonder black holes are the densest objects in the universe. Located just above the northern horizon this time of the year is the star Vega. It's the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of our Sun, and it's a relatively young star, less than 500 million years old, and it's also fairly close, just 25 light years away. Now, once again, due to the precession of Earth's rotational axis, Vega used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquila or Altair, the brightest star in the constellation Aquila. It's a spectral type A white-yellow star with about twice the mass of our Sun. Altair is located really nearby, just 16.7 light years away, and it rotates very rapidly with an equatorial velocity of about 286 kilometers per second, and that's a significant fraction of the star's estimated breakup speed of around 400 kilometers per second. Now, this high rotation rate means Altair isn't spherical, but highly flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water bearer for the gods. Looking to the southeast now, and you'll see the bright star Achernar. It's the brightest star of the constellation Eridanus the River. Located around 140 light years away, Achernar has 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter being about 56% wider than its polar diameter. September also sees the bulk of the Aurigids meteor shower, which is produced as the Earth passes through the debris trail left by the comet KESS C1911N1. KESS is a long-period comet, only reaching the inner solar system every 1800 to 2000 years. Its meteor shower runs between August the 28th and September the 5th. The Aurigids provide up to 5 swift and bright meteors an hour, with its peak just before dawn on September the 1st. It's best viewed from the northern hemisphere as its radiant, that is, the direction the meteors appear to be coming from, lies in the northern sky constellation of central Auriga. A second meteor shower in the month of September is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids shouldn't be confused with last month's Perseids meteor shower. That's because while both appear to have their radiant in the constellation Perseus, they're caused by debris trails from 2 very different comets. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the September night skies on SkyWatch.
G'day, Stuart. Yep, September, nice viewing from where I am at least. It's actually a great time of the year for stargazing. We've got Sagittarius and the galactic centre overhead in the evening if you live down in the southern hemisphere like I do, and the summer constellations are beginning to come up in the early morning sky. So we're sort of getting the best of both worlds. We've got the sort of winter constellation still and some of the summer constellations turning up. So it's a good time of the year. Well, let's start though, as we usually do, with the Milky Way and the constellations and see where that is. So at the mid-evening during September, we've got the Milky Way, which of course is our home galaxy seen from the inside, and it's stretching right across the sky from north to south at about 8 o'clock or so at night. So for those of us at the sort of middle latitudes in the southern hemisphere, the centre of our galaxy and the star fields of Scorpius and Sagittarius are more or less directly overhead, which is brilliant. So if you've got some dark skies, you can go out and you can see these beautiful star clouds up there. This region is great to view, even with just with a pair of binoculars. But do try to get away from nearby sources of light. So don't stand under street lights. Don't stand on your back porch with a light above you, that sort of thing. Any lights that are around you, try and block them out by standing behind your house or behind a building or behind a tree or something. You've really got to get as much darkness as you can.
Yeah, I always get arrested when I do that.
They know you by now. Oh, it's him again, yeah. So this area, the night sky, the Sagittarius region particularly, you can just spend hours and hours and hours, multiple nights, just sweeping back and forth through this area with a pair of binoculars or a telescope that's got a wide field of view, because there's just so much to see. An almost endless list of things, really, and famous deep sky objects like the Lagoon Nebula, the Trifid Nebula, the Eagle Nebula, the Wild Duck Star Cluster. All sorts of things are found in this area of the sky because we're looking in towards the centre of our galaxy, so right in towards the centre of the sort of stellar city that we live in. If you imagine our solar system's like a suburb, we're looking straight into the heart of the stellar city that is our big galaxy. So brilliant time of year to see that if you live in the southern latitudes. Way down south, we've got the Southern Cross. It's lying on its right-hand side, and the 2 pointer stars above it, Alpha and Beta Centauri. Now, if you have really dark skies and you've let your eyes adapt to the dark, you'll see that just next to the Southern Cross, there's this big dark patch in the Milky Way. This is actually a huge cloud of dust and gas that's floating in space called the coal sack. They call it the coal sack because it's just this inky black nothing that seems to be there. And initially, you might think, oh, that's like a big hole that we're looking through the Milky Way to whatever's beyond. But no, it's just a big cloud of gas and dust that's blocking the stars that are behind it. It's opaque to the light from the stars behind. There are a few stars in front of it, but it looks really, really good. And particularly if you can really get out in the countryside, where you don't have any lights at all and you've let your eyes adapt to the dark for 20, 30 minutes or so, and you look up and you see the Milky Way, it's just full of these dark areas all the way through it. And in fact, it's interesting that a lot of cultures formed constellations by a sort of join-the-dot affair with bright stars, or some other cultures, including some indigenous Australian cultures, instead chose to look at the dark patches in the Milky Way. And they made up their tales and their mythologies and legends according to the dark patches, as well as some of the bright stars as well. Just near the left-hand, staying in the region of the cross, just near the left-hand side of the Southern Cross, as you see it at the moment, that's the one that's uppermost, the star that's uppermost in the sky of the 4 or 5 stars in the cross. If you get a pair of binoculars and put it onto that star and just move it a little bit up, you'll see that there's a fantastic little cluster of stars called the Jewel Box. which for obvious reasons, because you've got these beautiful, bright, sparkly stars, and a few of them have got some colours. They're not all just plain white, and it looks really, really nice. As the night goes on and the Earth's turning, you've got stars disappearing in the west, and you've got stars coming up in the east as the Earth goes around, and the eastern part of the sky will seem to be quite bare, actually, in the latter part of the night and through into the early morning hours. But as you get past midnight and, about 1 o'clock, 2 o'clock, 3 o'clock or so, then the mighty constellation Orion will be coming up over the eastern horizon. So if you're an early riser, if you're getting up at 5 o'clock, 6 o'clock or whatever, and it's still dark, then you'll see the huge constellation Orion with its magnificent star pattern coming up over the horizon. For astronomers, this is the sign that the seasons are changing. For us in the south, it means summer's coming. For people up in the north, it means winter's coming. There's also the constellation Taurus, which is really easy to spot once you know what it is, because it's got this fantastic wedge shape of stars at the front of it called the Hyades. Another constellation that's also nearby and it's got the brightest star in the sky, Sirius, is a constellation called Canis Major, which is the larger dog. There's a Canis Minor as well, and the brightest star in that one is called Procyon. Not as bright as Sirius, but still a pretty bright star. So those constellations coming up in the morning are an indicator that seasons are definitely changing. Now let's have a look at where and when we can see the planets this month. Mercury is low down on the western horizon after sunset for the first 2 weeks of September, but then it's going to disappear from sight as it moves in between the Earth and the Sun in the third week of September, and we can't see it obviously because it's in the glare of the Sun. Venus, which normally is big and bright, either in the evening or morning sky, it is lost to view at the moment in the glare of the Sun because it's around on the other side of the Sun from us. And because it's sort of circling the Sun that way and we're circling this way, we're sort of playing catch-up. And it's going to remain basically behind the Sun from our point of view for the next couple of months. We won't get to see it again until late November, which is a bit of a shame because Venus always looks wonderful. But this does happen from time to time and nothing unusual about it. So if you like to see Venus, I'm afraid you're out of luck. And all through September, October and November, sort of very late November into December, we'll see it again. Now, the viewing conditions for Mars are slowly getting better. The red planet is going to be at its closest to us in December. So that means that as the weeks are going by, we're sort of getting closer to it. It's getting closer to us. And therefore, if you look through a telescope, it's going to appear slightly bigger and bigger and bigger as each week goes past. That said, Mars is a small planet, so it doesn't ever look really big through a telescope. But it has actually doubled in size, or apparent size, what it appears to us to be since the beginning of the year. So coming up to December, it's going to be even bigger still. And if you've got a reasonable-sized telescope, then you'll be able to get a good look at it. At the start of September, Mars is rising over the eastern horizon just a little bit after midnight. Now, the big one this month, Jupiter, it's the star of the show because it's reaching opposition on September the 27th. Opposition is when a planet and the Sun are in opposite directions as seen from Earth. And this means that as the Sun's going down in the west, the planet's coming up in the east, and we've got all night to look at it, which is what astronomers like to do. And it's also pretty close to the time, within a day or a few days or a week or so, generally, of when the planet is close to us as well. Now, you find Jupiter in the eastern sky after sunset at the moment. You can't miss it. You really can't miss it. It's big and bright, and even a small telescope will show you that the planet has cloud bands, and you should be able to spot several of its moons too. They just look like tiny pinpoint of light. You're not going to see any detail on the moons. In fact, you can actually spot the moons with just a pair of binoculars as well.
And you can watch them change position too over a couple of nights.
Yeah, I was going to say, if you go out, the following night, you'll see that they've moved, and then the night after that, they'll have moved again. Sometimes you'll see 4 of them, maybe 2 on one side and 2 on the other, or 3 on one side and 1 on the other. And the next night they'll be all different again, and so on and so on, because they zip around the planet pretty quickly. And what else we got? I've got Saturn. Now, Saturn was at opposition last month, opposite sides of the sky, but the viewing circumstances are still really good, even though it's a month past opposition. And even more so than with Jupiter, the view of Saturn through a telescope is just superb, even a small telescope, because you can see its rings, which really look quite specky. I think they're about 14 degrees tilted to us at the moment, which is not too bad. Only a few years from now, actually, the angles between us and it being Saturn, are going to line up such that the rings will be edge on, and we won't see them for a while, which looks pretty amazing as it is. If you're used to seeing Saturn with rings, when we get to this, what's called ring plane crossing, then the rings seem to disappear. It does look quite odd to see Saturn there without any rings. So anyway, finally down here on Earth, it's September, of course, and that means we've got the equinox coming up, which this year is going to be on September the 23rd. Now, in some parts of the world, the equinox is considered to be the beginning of the relevant season, either autumn or spring, depending on which hemisphere you're in. In other parts of the world, the equinox is considered to be roughly the midpoint of that season. Not exactly midpoint, but roughly the midpoint of the season. And there are other parts of the world still where, such as the tropics, I'm thinking, where autumn and spring really don't apply in a local sort of sense because they just have a wet season and a dry season. So it all depends on where you are.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.